Most people use a smartphone every day. It feels simple: smooth glass, thin metal, one screen. But inside this device are hundreds of components, sourced from all over the world and assembled through one of the most complex manufacturing systems on Earth. Each smartphone part comes from a different place. Different factories, different countries, different supply chains. A single smartphone may contain materials sourced from more than 20 countries. No single factory makes everything. Before assembly begins, raw materials must be extracted from the earth. These materials form the physical foundation of every smartphone. At the center of every smartphone is silicon. It is the base material used to create the processor, the brain of the device. Silicon starts as ordinary sand. Through high-temperature industrial processes, it is refined into ultra-pure material. Silicon wafers are shipped to semiconductor fabrication plants. These facilities operate at microscopic precision. Modern processors contain billions of transistors. Each one is smaller than a human hair. Once manufactured, chips are packaged and transported to assembly facilities. This is only one part of a much larger system. Every smartphone depends on a rechargeable lithium-ion battery. It stores energy, controls power flow, and determines how long the device can operate. Lithium-ion batteries are made from specific raw materials, including lithium, cobalt, nickel, and graphite. These materials are processed into battery cells inside specialized factories. Each cell must be manufactured with extreme precision for safety and reliability. Before installation, batteries are tested for capacity, voltage stability, and thermal safety. The display is the most visible and fragile component of a smartphone. It combines glass, light-emitting layers, and electronic control circuits. Smartphone glass is chemically strengthened to resist scratches and impacts. Display panels are fabricated in cleanroom environments to prevent contamination. Smartphone cameras are compact optical systems made from multiple lenses, sensors, and stabilization components. Each camera module is assembled and calibrated to ensure accurate focus, color, and image alignment. Once completed, individual components are shipped to final assembly plants. Only then does the smartphone begin to take physical shape. At the center of the phone is the main circuit board. This is where processing, memory, power management, and communication all come together. Before components are added, the circuit board itself must be manufactured. This involves layering copper traces onto fiberglass substrates. To attach electronic components, solder paste is precisely applied to the board. This paste will later melt and form electrical connections. Automated pick-and-place machines position thousands of tiny components in seconds. The populated board then passes through a reflow oven. Here, heat melts the solder paste, permanently bonding components to the board. After soldering, each connection must be inspected to ensure electrical reliability. Boards that pass visual inspection undergo electrical testing to confirm proper operation. Sensitive components are protected with metal shielding to prevent interference. Once completed, the circuit board is ready to be installed inside the phone. With all major components prepared, the physical assembly process begins. The physical structure of the smartphone starts with the frame. It provides rigidity, alignment, and protection for internal components. Frames are shaped using CNC machining, where cutting tools remove material with extreme precision. After machining, frames are polished, anodized, or coated to improve durability and appearance. Before assembly begins, all parts are staged and aligned for efficiency and accuracy. Assembly starts by installing the main circuit board into the frame. This connects the phone's electronics to its physical structure. Flexible cables link the circuit board to the display, battery, and sensors. The battery is installed next, providing power for all phone functions. Camera modules are installed and secured to ensure proper alignment. The display is attached last, sealing the internal components inside the phone. At this stage, the smartphone finally looks like a complete device, but its journey is not over yet. Once assembled, each smartphone is powered on for the first time. This confirms that the device can receive power and function correctly. Technicians verified basic functions, including display response, charging behavior, and system startup. Each touchscreen is color accuracy and brightness are calibrated to meet strict visual standards. Camera systems are calibrated to ensure proper focus, alignment, and image clarity. Speakers and microphones are tested for volume, clarity, and noise levels. Internal sensors, including accelerometers and proximity sensors, are verified for accuracy. Physical buttons and ports are checked to ensure durability and responsiveness. Automated systems scan each device for defects that may not be visible to the human eye. Only devices that pass every test move forward. Those that fail are removed for repair or recycling. Before shipment, smartphones must survive conditions far beyond normal use. Drop tests simulate accidental falls from pockets, hands, and tables. Displays are tested for impact resistance to reduce the risk of screen failure. Smartphones must operate in extreme heat and extreme cold. Humidity testing ensures internal components remain protected from moisture. Vibration tests simulate transportation and long-term mechanical stress. Physical buttons are pressed thousands of times to test durability. Charging ports are tested for long-term wear caused by repeated cable insertion. Devices are powered on for extended periods to detect hidden electrical or thermal issues. Only smartphones that pass all stress tests are approved for final software setup. After physical testing, the smartphone is still incomplete. Without software, the hardware cannot function. Core firmware is installed first. This allows the phone's hardware to communicate internally. Next, the operating system is installed. This controls everything the user will interact with. Software is matched precisely to each hardware configuration. Security systems are activated to protect the device and its future user. Each smartphone receives a unique identification number, allowing global tracking and authentication. Wireless systems are tested to ensure reliable cellular, Wi-Fi, and Bluetooth connections. A final system-wide check confirms that hardware and software operate together correctly. Before packaging, devices are reset to their factory state. At this point, the smartphone is complete and ready for global delivery. Before packaging begins, each phone is cleaned and inspected one final time. Protective films are applied to prevent damage during transport. Packaging boxes are assembled to protect the device during shipping. Each phone is placed into its box, along with accessories and documentation. Boxes are sealed and labeled with tracking and destination information. Individual boxes are stacked onto pallets for efficient transport. Pallets are loaded into shipping containers bound for global markets. Smartphones are transported by trucks, ships, and aircraft, often crossing oceans. Once delivered, devices are distributed to warehouses, carriers, and retail stores worldwide. From raw materials buried deep in the earth to a finished device in your hand, a smartphone represents one of the most complex manufacturing systems ever built.